Today in class we learned about cell notation, and in the book we use the equation Zn solid plus Cu 2 plus aqueous goes to Zn plus 2 aqueous plus Cu solid. Okay, and then after this, now that we have our formula, we can write the cell notation, and we have to find out which one's oxidized and which one's reduced. So the one that's oxidized is the Zn solid, which transforms into the Zn plus 2 aqueous. And then the reduced one is the Cu2 plus aqueous, that transforms to the Cu solid. And after that is done, and now we know which one's oxidized and which one's reduced, we can write our notation, which is, and this is how it looks like. So the Zn and the Cu are right here, and then there's a salt bridge right here, and then there's like this apparatus thing, and then it goes like this. This one is negative and this one is positive, and so it travels this way, and then the salt bridge enables it to kind of like complete its circuit, which makes it again go negative to over here, and then the cycle just starts like that. And so that's how it's formed, and there's a picture in the book that's like that. So we have to do the notation. So it's always oxidized and then reduction. So it's going to be Zn solid, phase change, that's how you indicate a phase change, Zn 2 plus aqueous, and then salt bridge, that's the salt bridge, and then it's Cu2 plus aqueous, and then phase change because it goes into a solid, Cus, and then that is your cell notation for that part. And so after we did that cell notation, we did how to calculate the E naught of the cell, and we use this formula, E of cathode minus E of anode, and we find these values in the table in our chemistry book. It's like the only table, I think, that it's extensive in chapter 18, and so wherever our cathode was, which is our reactant, or the one that gets reduced, and this one is the one that gets oxidized, we just found the equation there and put that value in here, and then found the other equation and then put the value in here, and then just subtracted it, and we get the E of the cell. And the E of the cell prefers to be spontaneous when it's positive. So positive, and then it's spontaneous. So remember that. Then we did a few examples that we found if it was spontaneous or not, just by looking at the table in the book. And then after that, we found the G naught, and we followed this formula, which is delta G naught equals negative moles of electrons, and then this is Faraday's constant, and then this is the E of the cell, which we just calculated, how I showed you a minute ago. And the Faraday's constant, well, it's a constant and you can find it at the end of the book, and then once you calculated your E cell, the only thing to do is find your moles, and you're going to put a negative after, and this is your electrons. And so for example, Cu2 plus Zn solid, this is aqueous, and then Cu solid plus Zn aqueous, 2 plus, they have 2 moles of electrons that are in this equation. So the number for moles is 2 in this equation. And Then after you have that, you have now your moles, for example. Now you just plug in your Faraday constant, and then you plug in your E of the cell, and then you get your delta G. And then that's how we ended, and we're going to do more examples next time in class.